Okay, it's 11:31. I'm going to go ahead and get things started. Good morning, everyone, and welcome to Asset Management, bringing our communities into focus. Thank you for joining us today as we kick off our webinar series celebrating Asset Management Month. I want to hit on a few housekeeping items before we get started. First off, I'm Matthew Largen. I'm today's host and a senior marketing associate with WithersRavenel. As you might have noticed, you are muted upon entry. That's by design, so we don't have people talking over one another or people yelling in the background. However, if you have any questions that come up during the presentation today, please feel free to use the chat box on your right in WebEx. We will try our best to get to those questions during the presentation. If not, we will follow up in other conversations about those. Additionally, this webinar will be recorded and shared on WithersRavenel's YouTube channel within the next week. At the end of the event, I will post a link to that YouTube channel. Just keep a lookout for new uploads, and we'll have this recording there for your access. With that said, let's jump into why we're here today. As I noted earlier, we're celebrating Asset Management Month, and the reason that we're doing that is because infrastructure is at an interesting spot right now. And some would say even critical. Our nation's assets are reaching the end of their lifespan, or they're becoming more vulnerable to natural disasters. This leaves communities facing tough decisions about how to prioritize repairs and, more importantly, how to fund them. What we're hoping that this month will do, and some of the content and webinar series that we bring, is some strategies and actionable insights to proactive asset management, to make sure that communities are resilient, that they have plans, and that they're prepared to tackle any challenges before they become any major issues. So with that, I know that we're going to have a great presentation today with Casey. And so let me introduce her, and then I'll let her take it away. So joining us today is Casey Dolan. She's a project manager in WithersRavenel's Asset Management Group. She holds a bachelor's degree in chemistry from West Virginia University and a master's in environmental engineering from NC State, specializing in water and wastewater treatment processes. She earned her professional engineering license and an asset management certification from the Institute of Asset Management in 2023. She brings extensive experience in asset management planning, water and sewer pipe design, and treatment facility assessments, with a passion for helping others advance their practices beyond completion. So with that being said, Casey, I'm going to hand it off to you. I know this will be a great presentation, and thank you for being here today.
Thank you, Matthew, and thank you all for being here with us today. As Matthew mentioned, we are going to be talking about asset management and bringing our communities into focus today. So I'm going to start our presentation today by talking about what is asset management, and more importantly, what does asset management mean to you and your organization. I'm then going to go into the different levels of asset management and how those levels can build on each other in increasing detail as you go. Then I'm going to go through what is an AIA and how that works in North Carolina, and then kind of talk a little bit about how that may be a possibility in other states, hopefully soon, or if not now already. And then I'm going to finish up by talking about a couple case studies of projects that I was able to be integrally involved in, starting with the town of Pilot Mountain and then going through the town of Liberty. So first and foremost, what is asset management? So there are a lot of different definitions that you can find out there. ISO 55000 defines asset management as the coordinated activity of an organization to realize its value from its asset. So I like to think of asset management by thinking of a car. So most cars come with recommendations from the manufacturer of maintenance or replacement of things that you should do throughout time and ownership of your car. Some things are like an oil change, where there is a set mileage, where they say every 4,000 miles or whatever, you should do an oil change on that set interval. And then there are other things that are kind of like brake changes. So for brake changes, there is not a set interval for mileage or time that you should do that, but there is typically a trigger like an alarm or a squealer to let you know when it's time to change the brakes. So much like a car, water and sewer assets have known O&M activities that are intended to increase the lifespan of the assets. And if these O&M activities are skipped, they can often decrease the life of the asset instead of increasing the life of the asset. So what does that mean for you and your organization? So I like to think of asset management as kind of the risk versus reward of your assets and kind of trying to get the most bang for your buck in terms of balancing the risk of failure of your assets and comparing that to the cost or time required for that repair or replacement of the asset. So now I want to talk a little bit about the different levels of asset management and how they build on each other in terms of increasing detail as you go. So first and foremost, I like to refer to the asset information that an organization has as the foundation of all asset management practices and systems and everything. So thinking about asset information is what are the primary components of your system? What is some information such as the age, material, size of each component? What is any existing information on condition or expected working life of that asset? Where is each component of the system located? Do you have a GIS mapping system? Do you use paper maps that tend to work for you? And then what is some information such as when does each component need to be maintained, rehabilitated, or replaced to continue maintaining the desired level of service for your customers and stakeholders? So then once you have a good foundation in your asset information, then moving into tactical asset management, you can work into things like maintenance and inspections. What are the things that we value enough to measure and report on? Are they meaningful? Are we collecting data that we can use to further our assets? What is our risk? So the likelihood and consequence of failure of our assets. How do we mitigate these risks that we were able to understand? And this is where we are able to really start to prioritize projects based on the asset information and the additional information we were able to find, and trying to be able to do a cost-benefit analysis to determine the best way to prioritize our assets. So then at the very top of the pyramid, is the strategic asset management. So this starts to look at the anticipated service life and understanding how the life cycles perform using predictive modeling. And again, looking at that cost benefit analysis using a little bit more detail to be able to understand the consequence of the decisions that we are making, and using all of this information and modeling opportunities to make good long-term investments and decisions so that we can look at the asset groups compared to one another and do a lot of the asset group planning together. And again, looking at a little bit more detail into prioritizing the projects and making sure that we're doing the right project at the right time to, again, get the most bang for our buck in terms of our funding and improvements to our system. So now I want to focus on the asset information questions, because like I've said a couple times, these asset information questions, I truly believe, are the foundation of any asset management practices, anything like that. So I like to think of it as the who, what, when, where, why, but in a different order. So what, again, gets at what is in my system and what do I know about the assets that are in my system. Where gets into where is each asset located? Do we know where it's located on a GIS map? Do we have an Excel sheet that shows us where each of our assets are located? How are we keeping that data of where our assets are located? So when does each component get maintained, rehabilitated, replaced, things like that, to again maintain that desired level of service that we have for our stakeholders and customers. And then we have who is responsible for not only this information, but maintaining this component and keeping track of what has been done with the component and what needs to be done, and when it needs to be done. And then most importantly, the why. Why are we doing all of this? Why are we keeping track of the work that's being done? Why did the component fail? Just understanding that why can help pull all of these questions together to make sure that we have all of the asset information that we need to have. So now I want to talk a little bit more about asset management and how the different aspects come together. So here on the screen, you can see a graphic from the Institutes of Asset Management that depicts a strategic plan. And on this graphic, I have highlighted kind of the 4 areas that I really like to focus on when we pull it from the strategic planning level down to the asset management plan level. So again, noticing that asset information is showing at the bottom center. And I know I've said it 3 or 4 times already, but that truly shows that it is the foundation of all of the work that is done here. And then along with the asset information, we have the risk and review, the asset management decision-making, and the strategy and planning. And all of these elements work together really well to form a sustainable asset management structure for the utility and organization-wide. So I like to talk about asset management plans as if they are the one-stop shop to explaining the entire system. So it's one place to hold all of the information that you all have for your system assets, what you're already doing to maintain your assets, and what are some new and interesting ways that you have learned to increase your asset management practices moving forward. So the purpose of your asset management plan is to deliver a near and long-term roadmap for proactively managing a system's water or sewer assets. And this asset management plan is going to provide some of those data-driven insights for the town to make some very informed decisions for not only capital planning, but also some of those operation and maintenance plan decisions, while being able to, again, balance and maximize your cost benefit analysis to, again, get the most bang for your buck that you can, so that you can make sure to continue to enhance those levels of service for your customers and your stakeholders. So what all of this means is trying to deliver the same or better levels of service for either the same cost or just making it more cost efficient. So again, you can get the most bang for your buck. So all of this is hopefully going to save time, save money, and save you a lot of headaches. So I want to pause here for a second and talk about, I had a town one time that was able to do all of these things and save them a lot of headaches in the future. So I had one client that I worked with that was doing some smoke testing, and through our smoke testing effort, we found a location or two where there was actually a manhole overflow into the swamp, and that was something they had not previously known. They knew they had some overflows, but they were never able to pinpoint it. And following that overflow upstream, we were able to find a stormwater sewer cross connection with the sanitary sewer that when it rained in town, the swamp's water level rose and that water was able to enter into the sewer system. And through our asset management plan preparation process with the town, we were able to use this known information of these overflows to make a plan to remove and decrease the stormwater sewer cross connections into the sanitary system. So the next thing I want to talk about is the AIA. So AIA, or Asset Inventory and Assessment, is a grant offered by the state of North Carolina that helps utilities increase their asset management process to become more viable and proactively plan and finance their systems. So if you are a North Carolina customer, how are you able to leverage this grant opportunity to increase your asset management planning efforts? And if you're not a North Carolina customer, what kind of funding may exist in your state that you would be able to do something like these asset management plans? So now I want to talk about my case studies. So I want to first start with the town of Pilot Mountain. So where did they start? So prior to our project, the town of Pilot Mountain had very little in terms of mapping, at least in a usable digital format. They had a lot of paper maps that they didn't really know how accurate they were anymore. They had kind of in their mind where a lot of their assets were, but they may not be reflected in some of these maps that they had. And then they also had a high inflow and infiltration throughout their sewer system, and they wanted to be able to pinpoint that to decrease what they were paying, or what they were paying to treat in their wastewater treatment plant. They also had a lot of pressure issues in their water system. So they had some areas where they had a little bit too much pressure for what they desired. And then they had some areas where they had low pressure concerns, both by their residents and what they were seeing in some of their records and things. And lastly, they had an issue. They have 2 tanks in their system, and they were noticing that one of their tanks was struggling to fill properly, or it would fill and it would overflow. So they were trying to better understand why that was happening. So now I want to talk a little bit about what we did in our project and what they're able to do moving forward. So here on the screen, you can see those 5 questions that I brought back, and I have 2 of them grayed out. So through the course of this project, we were able to fully answer the 3 questions that are the current state of my assets, which ones are critical to sustaining performance, and what are the best CIP and O&M strategies. And then the reason I have the other 2 grayed out is because we were able to answer these questions through our project, but these were identified as kind of in the next step of their asset management planning. They wanted to dig a little bit deeper into those 2 questions. So now I want to talk a little bit about what we did in our project. So on the sewer side of the project, we did a lot of mapping for them. So we had our field crews go out and field verify their manhole assets and all of their sewer assets, so that we could then use that data to do smoke testing to identify some of those inflow and infiltration locations, so that they could reduce the I&I in their system. Then we moved on and did a lift station assessment to look at their 19 sanitary sewer lift stations. They have 20, one of which is at the treatment plant, so we did not include that one in our study. But through that, we were able to see how efficiently each pump station was running, as well as what projects they may need to do in the future to help increase the state of that asset to make sure that it maintains functionality moving forward. And then using all of this information, we pulled it together into a risk matrix that looked at not only the likelihood of failure of these assets, but the consequence on the system to come up with a full story of the risk matrix to see and understand what projects we can put on their capital improvement plan to help them with their planning moving forward. So in our smoke testing, we were able to find a total of 206 defects in their system, and 133 of those defects were contributing to I&I. So that means that 133 of what we found were in low-lying areas where when it rains, the water tends to flow into the sewer system. I want to talk a little bit about what we found in the system. So a lot of what we found in the system are showing kind of here in the first two pictures on your left here. The picture on the far left of the screen shows where there is smoke coming out of the ground about 5 feet away from a manhole. And that depicts the sewer main was likely crushed there, or there was a hole where, I like to say, where smoke can get out, water can get in. So that was showing likely a crushed pipe near a manhole, but not right on top of a manhole. So then our second picture here in our pretty pink smoke, we have smoke coming out right around a manhole. And this is typically, and in this situation, it was because there were holes in the side of the manhole that was allowing water to pour in directly into the manhole. So I want to focus on these last three pictures. So this picture here in the middle, you can see it is a concrete structure with smoke coming out of it. So this was actually their decommissioned wastewater treatment plant. And prior to this project, the town's understanding was when this treatment plant was decommissioned, it was fully separated from their sewer system and should no longer be connected and should be a glorified pond at this point. And based on our smoke testing findings, we found that this was not correct, and that actually these basins were still connected to the sewer system. So every bit of rainfall that was collected by this old wastewater treatment plant was going right into their sewer system to be treated as sewer. And then these last two photos are connected photos. So they had another place in town that was an old dye plant in town, and it had been probably about 20 years since this dye plant had been in operation. And on site, they had this basin that was functioning as their on-site treatment facility so that they could pre-treat their wastewater before it flowed into the town system. And when the dye plant shut down, they were instructed to fully separate this this pre-treatment facility so that it would no longer be contributing to the sewer system. And through our smoke testing, again, we were able to notice that this was not separated from the town. So much like the decommissioned wastewater treatment plant, every bit of water that was getting into this old basin from their pre-treatment facility was getting right into the town's sewer, and they were treating it as if it was wastewater. So using all of this information, we were able to come up with some projects to put on their capital improvements plan for them to fix the defects that they could in the first two photos, and then come up with a plan to fully separate these abandoned infrastructure so that it was no longer collecting rainwater and putting it straight into their sewer system. So now I want to talk a little bit about the water project that we did. So much like sewer, at the beginning of our project, the town did not have an updated usable digital map of their system. So we did a lot of digital mapping and field verification to increase the attribute information and location that they had on their water system. And then we also did a valve analysis to better be able to pinpoint where the town could increase their number of isolation valves through their town so that they could better isolate when they had water main breaks, so that less of the town had to be shut off for them to fix these breaks. And then we were able to pull this together to do hydraulic modeling to look at the hydraulic characteristics around town to see where there may be pressure issues that they're experiencing, or see where might not have adequate fire flow, and also see if we can figure out what was occurring with that storage tank that was not functioning as expected. And then we were able to, again, pull all of this information together to do a risk matrix that combined that likelihood of failure and consequence of failure so that we could come up with overall risk scores to help us create proper capital improvement projects that we could prioritize to help the town optimize their planning for capital improvements. So the first thing that we did with the valve analysis was we looked at the number of valves on each pipe crossing and pipe T. So pipe crossings are where 4 pipes meet each other, and according to North Carolina design standards, each pipe crossing should, in an ideal world, have at least 3 valves. And as you can see here, we have about 40% of the pipe crosses throughout town that did not have the proper number of valves on them. And then similarly on the pipe T's, this is where there are the 3 pipes that connect to each other. And according to North Carolina design standards, each pipe T should have at least 2 valves on them. And as you can see, we're about a 50-50 split on the pipe T's of how many have the proper number of valves and how many do not. And using this, we were able to put the pipe T's and crosses that did not have the proper number of valves on a map so that we could identify with the town where the best places to put valves now to increase their ability to isolate their system for maintenance. So in our hydraulic model of the system, we took a look first at fire flow, which is, as we know, important for fire protection, as well as the town's insurance standard ratings. And we were able to identify some areas in town that were not currently meeting the desired fire protection level. So we were able to kind of talk to the town about potential plans moving forward to take more look at these areas to see if they were places where either replacing pipes would help them to increase this fire protection, or if this was a situation where we would need to add a loop to help their fire flow availability. So then the next thing that we looked at using the hydraulic model was the pipe pressures throughout town. And these are, again, important for state standards, but more importantly, these are important for customer satisfaction, water age, water quality, things like that. And we were able to identify that the area over here on the right side that you see here in yellow is very close to the storage tank that they were experiencing some issues in. So we were able to look at this hydraulic model and pinpoint a potential project that could increase the pipe pressures in this area, as well as alleviate some of those issues of that storage tank. So here we were able to identify a solution for that tank, and what we ended up seeing in the hydraulic simulation was that the best way to increase the sustainability of that tank and make sure it was filling and emptying properly, as well as increase some of the pipe pressures around that tank, was to better connect the two tanks throughout town. So the other tank is down here. It's a little bit further away, so we had to zoom into the map so you can't see the other tank. But being able to upsize an existing line and extend a little bit more line to better connect these two tanks was shown in the hydraulic model to increase the hydraulic efficiency throughout town, and like I mentioned, be able to also increase some of those pipe pressures that was found near that tank. So like I mentioned, then we pulled all of this information together to create this risk matrix where we talked about the likelihood of failure and the consequence of failure of the assets in town. And this made us able to use this to create the proper capital improvement plan for them to optimize their repair and replacement planning throughout town for the right assets to help them get the most bang for their buck. So now the plan moving forward for Pilot Mountain, since the conclusion of that project, they have been able to identify and work through some of their rehabilitation projects throughout their water and sewer system. And for that, they used some town funds, and they also submitted some funding applications to be able to fund some of their projects. And we're also currently in the process of doing a new round of AIA funding so that we can expand upon what we did in this first project to be able to include elements such as a water audit to help identify areas around town where they're losing water on their water system, and then also take a look at the hydraulic model to update and add in the fact that they are now connected to the town of Mount Airy to purchase water. So being able to update and see how that interconnection has changed the hydraulic characteristics throughout the town. So now I want to talk about my second case study, which is the town of Liberty. So prior to our project with Liberty, the town was doing some rehab and replacement of their water and sewer assets, but they knew that the GIS map that they were using was incomplete, and there were some areas that were not adequately showing the information such as age, size, and material of their assets. So it was causing them to have a little bit more of a haphazard capital improvement plan creation, and their rate increases were not as funded in, I guess it was not as funded in the math as they would want to. They kind of just went as they could with the information that they had, but it was really important to them that we include a rate study in our project. So then for this project, what we were able to do is using our project, we were able to adequately answer all 5 questions for both the water and sewer system and identify that moving forward, their asset management planning would really just be expanding on and getting more detailed information for each of these questions. I first want to talk about their sewer system. So like I mentioned, prior to this project, the town had a GIS system, but they were not very confident in the GIS that was done. So what we were able to do was go into the field, do some field verification, and collect attribute information on their manholes. And we were almost able to do all of the manholes in town. And then using that information for the sewer system, we were able to do a condition and criticality analysis so that we could help develop a capital improvements plan based on this information that we had gathered and our analysis. And then we were able to do a life cycle model that used all of this information and created a long-term funding strategy so that the town could see how their current level of funding for their capital improvement projects were affecting the town, and how over the next 100 years their plan may have to shift and evolve to allow the town to continue providing the same level of service to their customers. And then we were able to use all of this information to perform a rate study to help the town have a little bit more information on their analysis to determine proper rate structure and rate increases to help fund their capital improvement plan. So like I mentioned, in this project, we did some manhole attribute collection. So we did a field verification of 600 of their 618 manholes throughout town. And this kind of included, opening up the manhole, as you can see, taking a picture, gathering information such as depth, manhole material, manhole condition, and the material and diameter of all of the pipes that were connected to each manhole. And then we used this information to do the criticality and condition analysis. And as you can see here on the graph here on the left, it looks like their system is in pretty good shape, with only about 5% of their system falling into that poor condition category. And then looking at the criticality analysis graph that is showing here on the right, it looks like about 75% of their system was considered not to be critical, which means about 24% of their system was considered to be critical, whether because it was in close proximity to natural waters, in proximity to critical infrastructure, or it was not currently meeting the state design standards. So then hopping over to the water system, the town of Liberty had a little bit more advanced of water GIS. So we did not have to do as much field verification for their water system. So we were able to include a hydraulic model in our project to create a better understanding of the hydraulic characteristics through their town. And then we moved into that criticality and condition analysis to help us inform our CIP that we created. And then we also used life cycle modeling to create some of those scenarios to look at a 100-year long-term funding strategy for the town and create a rate study to look at the CIP and the best ways to fund that CIP. So looking at the hydraulic model here, you can see that we have the map of the pipe pressures here on the left, and then we have the map of the fire flow on the right. And there was not much in either of those maps that really stuck out as a problem, with the exception of the kind of right there in downtown in the center of the map for the pipe pressures. So using that, we looked a little bit closer at the C factor of this model, which was, and the C factor is the pipe roughness. So what this means is when your pipe roughness value is lower, you have more hydraulic restrictions in that area. So looking at this, we really identified that these orange pipes were showing some hydraulic restrictions. So we wanted to dig a little bit deeper into that. And we ran an analysis to see if the model could predict places where there may be a valve that was closed. And as part of our analysis, we took this to the town and said, according to the hydraulic model, it's showing that in these areas of town, there's a valve that might be closed, and the town went and made sure all the valves that they knew about were open, and it still showed the same on the model. So we were able to discuss with the town and identify that these may be some areas where there might be a valve that the town doesn't know about, or there may be a valve that is showing that it's open, but the valve has failed and it was actually closed, creating some areas where the town could do a little bit of further analysis after a project to figure out what they can find out in that area. So the next thing I want to talk about is the life cycle modeling that we were able to perform. So using the life cycle model, we could show, like I mentioned, the asset's life over the next 100 years to look at how things like asset rehabilitation or replacement can affect the service state of the asset to help the town perform their rehab or replacement prior to the failure of each asset so that they can continue to maintain a proper service state for their assets. So looking at some of the data from the Town of Liberty's life cycle model, you can see here about that. In the dotted line is the service state of the town's assets. And then the blue bar chart at the bottom is the town's funding, annual funding strategy for their assets. And as you can see, there are a couple of different spikes in years 1 through 50. So year 12 is going to be a little bit more funding. Year 38, 39 is going to have a little bit more funding. But for the most part, they have a very, very predictive model here to show that having the adequate amount of funding will help them to maintain that service state of 2. And looking kind of at my years 50 through 100, you can see in the funding strategy how inflation starts to play in throughout time, and how that financial investment will be increased as inflation increases. So the last thing that we were able to do with the Town of Liberty was we did a rate study. So we used the 10-year capital improvement plan that we created as part of the asset management plan to develop a couple of different funding options so that they could properly balance the capital investments that were needed with trying to keep the financial impact on the ratepayers as low as reasonably possible. And using this, we were able to propose some new rate structures that after the project concluded, the town was able to adopt and use to both articulate to council and their customers why the rate structures were needed and have a little bit more data behind their decision making. So moving forward, the town was able to use the data that we collected, compiled, and analysis that we did to find some of those rehabilitation projects on their capital improvement plan that they could, again, either fund using town funds or submit some funding applications to get some grants or low interest loans to pay for their rehabilitation or replacements. And they are looking into and applying for their next round of AIA funding so that they can use this asset management strategy and continue to build upon it to continue to increase their asset management planning process. And with that, that is the end of my presentation today. So I want to thank you all for your time today, and I look forward to hearing from you with any questions you may have.
Yeah, thank you, Casey. That was fantastic. I haven't seen any questions pop up yet. Um, is it all right if we share your email, Casey, if people do want to get in touch with you after this?
Absolutely.
Okay. Um, I will post that in the chat here along with a few other links. If you joined us a little bit late today, fear not, this webinar was recorded and I will be posting it to WithersRavenel's YouTube channel within the next week. So just be on the lookout for that. I will also post a link for that below. As a reminder, we are celebrating Asset Management Month, and with that, we will have 2 more webinars as part of this celebration. And the next one is scheduled for January 28th, and it is going to be on asset management trends, new year, new insights for sustainable infrastructure, which will be presented by WithersRavenel's Malik Brahmi and Chris Vanderhayden from PSD Citywide. But with that being said, I think we're going to close things up today. I'm going to post those links so everyone can have them. There's Casey's contact. And then here is everything else as well. So with that, thank you all for joining. I hope you all got some good actionable insights from this. And thank you, Casey, for presenting today.
Absolutely. Thank you all for coming.
All right. Thank you.